Okay, let's start. So some announcements. Well, you know about the homework, I guess. The other announcement is about finals week. The project is due via CrowdGrader. I still have to build the upload site, but it's due on Tuesday of finals week in the evening, because that's the day in which we officially have the final for this class. For the project presentations, I will post a sign-up sheet. The problem is that the registrar's office has not yet confirmed which days and classrooms it will give to us for the project presentations. So I was today to talk, to our School of Engineering secretary for the reservations, Leah Khan, and she told me that we hope to know by Thursday. Okay. Every year, the registrar's office is quite late in allocating these extra classrooms we need because they have a lot of constraints, and so they are sort of delaying their committal to the classrooms. But I don't foresee a problem, except that I'm annoyed as you are by the uncertainty of not knowing exactly when we will be able to have the presentations. Okay? Yeah, it's during finals week. So there will be, I'm asking for a total of 4 slots in addition to the 1 3-hour slot we have. So there will be 5 3-hour slots. So kind of a marathon. We will have to bring a coffee in a thermos. But for us, not for you, right? You will be attending one only of those sessions. And so I'm sure that there will be ample choice for you normally what I ask is that people put down the time they prefer, a time that is possible, and the times that are not possible, right? And then I try to accommodate the preferences first, and then try to, solve the rest of the constraint problem by picking times that are at least possible for everybody, okay? So what I want to do in the remainder of the class is the following. And you can devour me with questions if you like, but what I would like to do is the following. I want to present to you how to deal with time zone, just because I promised always, and it's a bit, sort of, semi-interesting, I would say. It teaches you some techniques that may be useful for the project, okay? And then I want to go to something entirely different, essentially, and that is, I want to show you a sort of pleasant surprise. That is, by the time you have followed this class and you can write this code in Vue.js and you can build a simple server that we can put on App Engine, as I've done previously, you can actually develop for mobile phones for free. Not only for one mobile phones, for any brands, both iOS and Android. The other brands almost don't exist anymore, okay? But you can easily develop apps that actually you can even package for Windows and Mac OS X, in case you want to do that. And the idea is simply that once we are able to work with the JavaScript and Mac OS X, JavaScript and Vue.js, we are able to package our code in a way that it resides on the device instead of being served by the cloud. And we will be able to essentially use the capabilities of embedded web servers in Android and in iOS in order to deliver our application to users, in order to visualize the one-page application we write in HTML and Vue.js and make our application talk to the backend that we write. We need very little modification from anything we have been doing. The modification is so small that it's ridiculously small, and we can essentially go from an application that is written on a server to a model where the application actually resides on users' phones, and the server still does as backend, the answering, the implementation of the API methods. But the rest, this thing will behave to users as if it was a native phone app with its own icon on the phone and normal behavior. So I think it's a nice surprise, that we can sort of not only build for web, but actually we can kind of build also for phones. So are there questions about the homework yet? The deadline is tonight, right? Any special difficulties? I saw many people that on Piazza, and I replied to only some. Unfortunately, sometimes it is crazy days in which I'm running from one thing to the other. But I saw that there are still doubts about how to get the list of users. But probably the people here know how to get the list of users by now and do this kind of thing, right? Is there any question that you want to ask me now? Any device? Yeah? Sorry, there was one back there. Sorry, I couldn't hear well. Can you say? If the images disappear after you refresh the page, that may be a sign. I mean, it sounds so stupid because it's obviously so, but that may be a sign that something goes wrong. Haha, very, very informative reply. No, what can possibly go wrong? I mean, one of the most common things is that you uploaded the image correctly, but then you fail to store the image in the database. You need to store in the database the fact that there is a new image by that user. And the problem is that if any of that is missing, it doesn't work. For example, if I insert the image, but I forget to say to which user it belongs, then when I refresh looking for my images, I won't see it anymore, right? So that's a possible mistake. Another possible mistake is that you don't store it on the server. I mean, there are several possible, I guess. Other questions? So, if you have a problem like that, by the way, let me just add that I think one of the most difficult thing to do in this class compared to other classes is debugging, because you have several places to look when there is a problem. So let me just remind you, you need to look at the JavaScript console, at the network tab to see whether you are sending information back and forth. You need to look at the Web2Py output because there might be an error in the server processing in Web2Py, and you need to look at the database state. So that's already 4 places where you need to look before you have some idea of what may go lost. 1 second, there was a, yeah?
I saw your post about how to make a list of users. I did it a little differently. So the user only shows up on my list if the user's already uploaded an image.
Yes.
So it has to have at least one image uploaded because that's when it goes into the database. Is that fine? Or?
That is even better, and I would have liked to give people a solution like that, but I figured that if people were asking the question, it's probably because they wanted to have the simplest solution, not necessarily the most refined. So your solution in which you only give out users who uploaded at least one image is actually a better one. Yeah. Yes?
So you mentioned the database state as somewhere where you can look to see problems. How would you go about that?
Yes, this is a bit inconvenient. So there are 2 ways. There is the way I don't use and the way I use. The way I don't use, I need to bring up a Web2Py app. 1 second, okay? So I can, let me see if this is supposed to work. What was it? Localhost 8080. I think I was opening with this one, with my Firefox Developer Edition. 1 second, it will come up. So the easier way is the one I don't use, and it works as follows. Localhost 8800, I believe, is where we are working. Yes. And so if you go to admin, it will ask you for the password, okay? And then at this point, in any of these apps, I guess, it doesn't really matter. Oops, it may matter. Yeah. Well, let me go to the Start app. You can click on Edit, okay? This gives you a way, by the way, to edit the files so that I normally edit via PyCharm, but you could edit them also this way. And what I want to do is click on Database Administration. This will give us a GUI to stare in the database. So I click here, and this is giving me the list of all the tables. I don't quite know why these are the tables we have. okay, but they seem to be the tables we have. So you can look at example table, and this will give you the list of elements of the example table, which is 1, Chao, and 2016, and these. Oh, I know why this is happening. I think I might have, while I was in my office, switched between different branches of the repo in order to show you this time zone code, okay? But essentially, you can look at all the records, you can select one record, look at it. Let's look at a different table, for example, that might be more interesting, auth user, right? You can click on it, and it tells you that there are two users. These are the two users, Luca and Luca. Okay, and so if you look at them, you can see first name, last name, email, etc. So this gives you a way to poke into any table, and it's actually quite convenient. Perhaps that's the way I recommend. If you want to use the way I've been generally using, you use SQLite and you type a command. You go to the databases directory and you type this command SQLite3 storage.sqlite. Okay, and that opens an SQLite console, which gives you access to the file. And I find it very convenient because I remember the SQLite commands by heart, but you may find it less convenient unless you are more used to databases. Okay? A smaller advertisement for SQLite, by the way, just as a general culture. SQLite is a database that stores its data in a single file. It has very poor performance if you try to write to it from multiple independent processes. Because if you have the database in SQLite, it either locks when it tries to lock the database to give exclusive access to one of the writes, it actually locks the entire database. So there can be only one writer at any given time. You understand that if you have a database such as a bank where you have a lot of transactions, you would like to be able to modify different rows of tables without having to lock the global state of the database each time you do a single write. Okay, so it's not a database that is very good for powering concurrent websites where we have a lot of independent accesses. But it is one of the very best ways of storing information locally in a way that makes its retrieval incredibly fast. So it has two advantages over other solutions. So for example, when you write floating point numbers in SQLite, okay, SQLite actually writes the binary representation of floating point numbers. You may be very nonplussed, okay, saying, what that is. Why would that even bother my consciousness? And the problem is that if you ever look at the routines for converting from binary to ASCII and vice versa floating point, you will discover that there is a lot of code that is executed in those, okay? So it's conceptually easy, and I think you have studied in something like CE12 or some such class, but it's computationally intense because you have to go over this binary representation of a mantissa and exponent, and you have to work on it to spit out the digits. Okay, so for example, reading a table of numbers, a very long table of numbers from SQLite or from CSV can have a speed factor difference I've observed of up to 50. No, which is very remarkable. I mean, sometimes when you loop over big CSV files because you do data science, you are actually spending most of the time converting ASCII into floating point. That's where most of the cycles go, okay? The other point for which SQLite is great is that now it's less of a problem because everybody is using x86 and Linux, or mostly. But the ordering of bytes on disk when you write integers or floating points didn't used to be standard across architectures. So there were funny architectures, IBM mainframes of various crazy types, that sort of used a different byte order. And so, these byte order issues are actually handled for you by SQLite. So the format of the file, the binary format of the file, is consistent across architectures. And for these kind of reasons, in Android, for example, a lot of the configuration is kept into SQLite files. Okay, so if you need to write stuff to a file and be able to read it for yourself in any super efficient way, SQLite is really quite good. The other thing you may look at is pandas, if you have huge tables of numbers. Okay, end of the parenthesis. Now, other questions? Oh, yeah?
Can we ask about homeopathy?
Sorry?
Can we ask about homeopathy?
Absolutely.
So I'm stuck at the part where you want to show that a user has checked out, like, or that they have in the shopping cart an image, or they put an image in the shopping cart.
Yes.
And I'm not sure exactly the best way to go about doing it, because I thought about doing it in the database, but then the problem with that is obviously that every user will have the same things checked out.
Okay, so there are two things. How would you do it in the database, which I don't ask you to do, and how do you do it locally, okay? Actually, let me go to the code that I gave you of my shopping cart, okay? And I will comment a bit starting from there. Actually, there is something else that I want to show you on that code that I haven't commented on enough. So let me go a moment to origin cart stripe single page. This is the tip of our nice branch that does the cart, you know, that I presented in class. And let me give you a couple of comments on that, and then I go to this local time zone. So, what I'm doing is something like this.
Excuse me, are you recording?
I think I am recording, but let me check. Yeah. So, sorry, now I lost track a moment. So I have this variable called cart, right? Here I have cart size and cart total, etc. But essentially, you can keep a local variable called cart in self-vo cart, if you will, and you can put that there, the things that you put in the cart. Now, in the homework, what would these things be? Well, I don't know exactly, you can decide, but for example, a simple decision is this. When you display images, you probably have a record that says image, and you probably, I'm not sure, because it's up to you how you implement, right? But a common choice would be to have an object that has two fields, like image.id and image.url. And also image.price, I guess, right? And also maybe image.owner or user or, you know, something like that. I mean, I'm not sure that you use all these fields, but you have this image object, right? So why doesn't your shopping cart contain simply a list of these objects, right? And you can say, for example, when you buy one more thing, then you can say, self.vo.cart.append is not called append, how it is called, push. And you push to it the image you bought, right? And now you may not want to just push it because you may avoid buying twice a copy of the same image as we discussed. And so in that case, you may want to first loop over the array to check if there is already an image with that ID, and if there is, you do nothing. And if there is not, you push it to that array. And then you have an array of objects, and that's your shopping cart. Okay? So this is a super simple implementation, okay? Is this clear to everybody? Now, if you want to send it to the database, then you need to do something slightly more complicated, because what would be a database cart? Imagine that you can you can buy only one copy of each image, okay? How would we define a suitable database table? Yeah, this is something I want to tell you for the next part of the class. How would you keep this table? Define table like cart, okay? And now here I have to define some various field now that I want to put. And what would this be? Any idea?
That item you're buying?
Yeah. So this would be like item ID, right? And it would be a reference image or something like this, right? and the other one would be like buyer, which is would be a reference db auth user, something like this, no? Or actually, I think I can say reference auth user, no? I think it would be something like this, because it's a many-to-many relationship, right? And so when I know your user ID, I would look it up under buyer, and like you would have a function that says def, this is a store cart, no? And it would say something like this. Let me try to write it on the fly. So, okay, there is a little bit of thing. I imagine that when you tell me to store the cart, auth require a signature, okay? But I imagine that when you tell me to store the cart, I'm taking you at face value on that. Anyway, the payment is going to be the payment. What I mean is this, that in the database I may have old stuff that comes from other things. Maybe your previous session when you were riding in the metro, with your phone. Now, however, you are sending me the cart, and I'm going to pay attention to these. So I would write something like this, db buyer, db cart buyer is equal to auth.user.id. So this is your cart, right? And I would simply cleave it on the server, because I don't want to listen to it. And then I would say for img in request vars cart, okay, you are sending me the cart, so I assume that that's where you give it to me. I mean, there are lots of assumptions, right? I'm just writing half of the code. I would say db cart insert, and I would say item ID is equal to img.id. And I would say also that that buyer is equal to auth.user.id. That is me, no? Because I'm the logged in user. Something like this, and then I would return response.json of okay, so that the server knows that I'm happy with it, okay? And def get cart, I mean, of course, you would require the signature, but let me write you the other method, okay? So to get the cart, you can simply say, sorry, moment thinking. You probably would like to get the images in the cart, right? Not really the list of image IDs. So how would I write this? Okay, something like this, for row in db, and then I would write a query that does the join, essentially, no? Because I would say, first that it's you. So db cart.buyer is equal to auth user ID. So this tells me it's you buying, and db image ID is equal to db cart item ID, I called it, okay? So this tells me these are the images bought by you. So for these, and I would say like image list is none at the beginning, is not code particularly written in a compact way, but I would say something like image list append dictionary of, I don't know, like image ID is equal to image.id. Wait, row.image.id, image, I don't know, I mean, it depends on how you are sending it, like image owner is equal to our image author, it depends on how you called it, right? And image URL is equal to r.image.url, something like this. And then, of course, at the end, I would do a return response JSON dict of cart is equal to image list, something like this. Okay? So these would be the two methods, and this would give you persistence on the server. Okay? As one more example for you to look at. Now, it turns out that you can also do another thing. So this is sort of very nice because you know, if I go shopping with my mobile phone, then, you know, I move to my table and swing open the laptop and I go to the same site because I decided that I really want to be able to type better. You know, because you fetch the list from the site, you would have the same list of products. There is a lighter weight solution to these, okay? So this lighter weight solution is actually very useful, and it's would have been my omission not to mention it in class. So browsers can have two types of information. They can contain cookies, right? And the problem with cookies is that for each website, you can store at most 4K of cookies, 4 kilobytes of cookies, which seems like a lot of cookies, but it's not, because they involve all the cookies that you are giving out. For example, one cookie will typically be a session cookie that will contain this long random string. Maybe that it's already 512 bytes or something like that. Maybe only 256, it depends, okay? But then if you have a lot of state for the user and you want to encode it in a cookie, these cookies tend to grow large. For example, in Web2Py, if you really go and look at what is happening behind the scenes, you will see that often Web2Py likes to put well, depends on how you configure it, but it can decide to put in cookies some pieces of your configuration that it often needs access to. So 4 kilobytes is not a lot of information. However, in the new web standard for browsers that is almost universally implemented, each site has something called the local storage. And the local storage is unlimited. I mean, the users get annoyed if you store a gigabyte, right? And there may be some limits defined in the browser configuration, but essentially it has a much bigger limit. And so in the application I wrote for you, I'm using the local storage as a way to store the information. Let's see how it is done, because it's really very, very simple. The drawback is that this storage, of course, if you move from one device to the other, I actually have to check what Safari does, but I don't believe that browsers sync their local storage. You know that Safari on multiple Apple devices syncs bookmarks and other stuff. Also, for example, in Firefox and Chrome, if there is a way to sign into your account so that you know, saved passwords and browsing history are synced. Super convenient. But I don't believe, but I'm not entirely sure, but I don't believe that the local storage is also synced. Okay. At any rate, let's see how this is used, this local storage. What I do is something like this. Sorry, I have to find it a moment. You see, the local storage is simply local storage, and it's an object. So you can set values to it. Now, what I'm just perplexed that. Sorry, I thought I was. Evidently, I'm being slightly cowboyish, because the problem is that you're supposed to check for the existence of local storage before you use it. But in this case, I was not. I was simply saying local storage is an object that is, you know, local to my website, right? So my local storage doesn't interfere with, say, Facebook local storage or whatever. So I'm simply saying local storage.cart is equal to, and now, this local storage, the only catch is that it's able to store strings. It's a key to string correspondence. It's not a fully complete, I mean, these is things that will need to be serialized and stored on disk, right? So it does not store arbitrary JavaScript data types in an incredibly crazy way. You have to transform it to a key value mapping where the value is a string. So what you do is, I take the cart, I convert it via JSON, because I know it's a list of objects and the object fields are simple. So in my example that I gave you in the repository, I could do that. I converted the cart content to JSON, and I simply store it in local storage cart. And so when I need to read the cart, what I do is simply this. If local storage cart contains anything, then I parse it and I put the value in cart. Otherwise, I start with an empty cart. Okay, so it's incredibly simple code, and it's incredibly convenient. And this gives you a very useful place where you can remember stuff for the short term. I mean, The only problem with the local storage is that you are not fully in control, right? The user may always decide to delete it. You know, there are these browser extensions or browser settings that say do not accept cookie, do not accept this local storage, clean local storage when you log out of the site. So there are all these various things, okay? And so, of course, people can always delete it, but as long as they don't, it's there. So, you know, that's a solution as well. Okay? Yes?
Do we have to define that anywhere, or do we just say,
No, you can just use it. It's crazy, yeah. It's predefined for you by the environment. Yeah.
Are there any browsers that don't have that?
Not any modern one. I mean, these are the things, you know, yes, you take somebody who is running a 12-year-old Mac without updating the browser and they might not have it. Yeah. But nowadays, you know, keeping the browsers updated is super easy, and so you would assume that almost everybody. I think I do have at home a machine on which I cannot install Chrome because it's too ancient. Okay. Okay. So other questions on the homework? I mean, I'm hoping sort of that this whole, I have the impression that some people found them hard. I was trying not to give them hard, but to have you play with all these various concepts. So I hope that this sort of works out. Now, let me go to local time. A moment. Okay, let me see. Okay, this switched entirely. Yes, I'm in default.py. So, what I want to do when I play with the local time is the following thing. I want to store all the times in UTC in the database, and I want to convert them on the way in and out. So, the problem is this, that it would be really easy to do if the browser would be kind enough to tell me the time zone of the user. Okay, but the browsers don't. At most, they tell you the local time of the user. Okay, but the local time is different from the time zone, because the local time tells you the immediate correspondence. For example, that now it is what time is it? It's 3:55 p.m. here, and so you know that in UTC that's another time, and so you know that we are, what is it, 7 or 8 with the DST is maybe 7 hours away from UTC, right? But the problem is that the time zone really contains more than that. It contains also the information on when these despicable daylight savings time starts and ends. And I say despicable because it creates a huge amount of mess, this daylight savings time. I mean, if you have ever worked on scientific applications that deal with the local time, you know that it's a pain that never ceases. No, because you do these graphs and then you realize that there are days in which it's twice a day, 2:30 a.m. in the morning, and how are you just gonna do the graph, right? Because you know, it goes to 3 a.m. and then the clock gets reset to 2 a.m. I mean, that's what happens in local time, right? It's crazy, but it's that way. How are you gonna do a good graphing application anyway? So this daylight savings time it causes all kind of craziness, you know. And just look at the train timetables for when the time changes, you know. They are quite interesting. So we cannot know the DST settings, so we cannot know the time zone. So essentially, somebody wrote a plugin that asks the browser to convert many times from UTC to local time, because that is something that the browser JavaScript can do at many points in the future and in the past. And from the answers, it deducts which kind of time zone you are in. Okay, because the browser JavaScript, in order to do these conversions, will rely on the operating system. And if the operating system is not buggy, and most of them are not, they have the table for the conversion from UTC to local time spanning some 100 years, back and forth. Okay? And so if you do enough queries, you can determine which time zone the operating system is. Okay? So that's how it is done. Now, in practice, what we do is the following. we want to add to each user a time zone setting in the user record so that we will be able to remember it. And we want to write our code in such a way that if we don't know the time zone, the browser will tell us once, and then we will remember from that time on. So let me show you how this is done. The first piece is the following. In the database table here in db.py, I want to add extra fields to a user. You know that if you go to the user profile, right now it tells you simply what's your first name and last name, etc. But it doesn't ask you other things. It turns out you can add other fields to the auth user table. Okay? Here I'm adding them here, you see? Auth settings extra fields, and I'm of the table of the user, and then I can give a list of fields that I actually want to add. Okay, this is useful for many purposes for projects. You know, if you want to add, for example, I don't know, age, or like maybe date of birth, actually, which is better, right? Not age. Or you know, like food preference. Are you vegetarian or not? Whatever. You can add it. In this case, I add a field that is called user time zone. It's a string, and this widget is some code that takes care in Web2Py, if you use the standard forms, of converting back and forth between UTC and normal time when you write or read the time. This, you know, we come later to this widget, but I added that field. And I put that definition above the auth defined table. So this will ensure that I can define my auth user table with extra fields. Okay? What else am I doing? Not very much here. But, sorry, I am a little bit lost in these various, okay, DB, okay. Okay, then I have, you know that the files in models get executed in alphabetical order. So db.py is, runs first, and then there is menu.py that just defines the line at the top. And then I wrote this myvalidators.py. Okay, this is where I do the mess with the local time zone. And I write a code that does as follows. I want to know if I know or do not know the user time zone. Okay? If I don't know it, I will be asking the browser to please try to decipher which one is the time zone and tell me. Okay? But so I have this global bit that says, if auth user is none, so where I'm trying in this code to do a best case analysis, and I want to do something as follows. You know, if the user is not logged in, where can I store stuff about the user? I can store it in the session, because the session, which is read with a user cookie, with a browser cookie, no, is something that will be associated uniquely to that particular user. So I'm saying, well, if the user is not logged in, if auth user is none, then I want to see if I'm lucky enough that in the past, due to previous accesses of that user to my website, I have user time zone session.user time zone set to something. If this is set to something, okay, and so I set the knownness of the user time zone consequently, and I also do a best effort imagination of what the user time zone can be. I say UTC if I don't know anything about the user, and otherwise if it is set, I use what is in the session, okay? If the user is logged in, then I look in auth user time zone. You see, user time zone is the name of the extra field we added, and so I access it just as I access the name of the current user by auth.user.firstname. The ID is auth.user.id, right? Then my new field is simply auth.user time zone. And so I do this ballet of actually reading it from the user record. And the only special thing that I do at the end is make sure that all this information coincides for logged in users. So essentially, if I know it in the session and I don't know it for the particular user, then I actually update the database. Okay, so I try to keep this information as consistent as I can. Okay? By writing it in the database as soon as I receive it in the session. Okay? So we will look later at what the UTC class is and does. Okay? Now the problem is, how do I get the information of the user time zone in the first place? I do the following. In the JavaScript, there is somewhere, wait, where is it? There is this plugin time zone, okay, which contains this particular JS timezone.minified.javascript. Okay, this is some piece of JavaScript that runs in the browser and is able to send back to me the time zone. And I do as follows. In layout.html, which is the general layout of the page, at some point I include this code. Okay, so first I load the plugin time zone. You see, normally you load things from static, but you can also load them from a the static JS, but in this case I load it from static plugin time zone. Okay, fine, you know, that's just the place where the plugin is. But then there is this small script that says the following: var tz name, time zone name, is equal to jstz.determine. This essentially asks, please, jstz plugin, determine the local time zone and give me the variable. Give me the name of it in this variable that I call tz name. And then I simply do a get. So essentially, I call back to the server. Actually, this should be a post. You should complain to me that I'm not being nice enough. Okay, this should be really a post. But in this case, I do a get because gets are slightly more efficient. Okay, I mean, perhaps is not the optimal way of doing it. But I call back to the server to a URL that I define default set time zone. Again, in the modern style in which I'm teaching this class, I should have called it API set time zone. Okay, but fine, I wrote it in a default file, and I passed to it the name of the time zone. Okay, and I actually only execute this code if time zone unknown code is set. I don't want to be if this if was not there, every time you load a page in the site, the plugin would be activated and it would tell me back the name of your time zone. But it's a waste, right? I don't want to send so many times the time zone. And so I only do it if the time zone is unknown. So basically, if the time zone is unknown, I load the code for determining it, and I get the name into tz name, and I send it back to the server. Okay? Now, when you send it back to the server, the code is in default, it's here, and this is the AJAX call to set the time zone information for the session. And what I do is, the usual stuff. I don't know if I should go slowly in the details, but essentially you get the tz name. If the tz name is a valid time zone, then I set it in the session, and if you are logged in, I also update the database. Okay, so I do sort of the semi-obvious thing. Okay. Yes.
So how often is the function set time zone
It's called only once. Normally it's called exactly once for each user, because if I build a website, it would work in the following way, right? You access once, the first time you load a page, your time zone will be unknown, right? So the plugin would be activated and you send me back your time zone. At this point, for your whole session, your time zone will be known, okay? And there are only two remaining pieces of subtlety that I do. First, I want that when you go create a user account, I want you to essentially freeze the time zone in which I know you are. You know, when you land on my website for the first time, you're not going to be logged in, obviously. So the first time you land on my website, the information on your time zone will be only in the session. When you create an account, I want to be sure that I store as part of your account your time zone. So where is that done? How do I know that if he is accessing from Hawaii, from now on he will be in Pacific Hawaii or however that time zone is called? Okay, that place is actually hidden here. When I define the extra table, oh boy, it's not defined there. No, but it must be defined somewhere here. Okay, let me find it. There is a place where I declare the default value for that field. Let me see if I put it in tables by any chance. Hey. Right. I thought I would store it. Interesting. Okay, I am at a loss, but I think I know how I did it. Hold on 1 second. Okay, so okay, so the other example, the reason in this class I'm not emphasizing anymore this business of the validators, okay? So let me just mention what they are and tell you that unfortunately this is a beautiful piece of Web2Py that I'm not explaining anymore in this class. But these validators, so you see that I defined that the DB example table created on requires as a date time validator. I'm essentially saying that the date requires this particular validator. And this validator is an instance of isLocalized date time. And isLocalized date time is defined here as this class which has methods to convert back and forth from local time. Now, this is all code that is very nice, okay? But I'm not explaining it anymore. What this code does is basically these two functions. If you give me a string that represents a date, I want to convert it, knowing your time zone, into a UTC timestamp that I store in the database. And then vice versa, if I read a UTC timestamp from the database, I want to convert it to a string, okay? This is done by this function that has a call method and another method because of the way Web2Py works. Now, you are basically going to write in JavaScript from now on. And so the only lines that are actually interesting to you are the ones for doing the conversion. So the key lines are simply these. Okay, I'm using here the time zone plugin to take a date. It's a bit nasty how to do it in Python. You have to essentially build a date. You have to replace its time zone to ensure that it is UTC, and then you read it out as the time zone in which you want to read it out. Okay, so this is a conversion in one direction, and the conversion in the other direction. So you can essentially read it here. You build a value, then you call these time zone localize method on it, and you read it as time zone UTC, and this gives you, the time that it would have been in UTC. So these are the two conversions, okay, in one and the other direction. And I think the best you can do is essentially read them for yourself. It's just code that manipulates in an extremely awkward way the two times. I just wanted to show you essentially how this is done. So what this causes is the following behavior. Okay, that if I go to this site, start. This has detected my time zone, and now if I sign up, okay, the user time zone is already pre-filled in with my suspected time zone, which is detected correctly. Okay? And so this is the extra field to the table that I've created. Okay? And in fact, if I log in with my usual login, hoping that it works, if I select login and I log in, now I can go to my profile, and you see I would be able to change any time zone I ever want via the widget. Okay? Yes?
So if you changed it on your profile like that, wouldn't your cookie or wouldn't the JavaScript try to update it?
No, it wouldn't, because if you notice how the code is written, the information from DB auth user time zone takes precedence. Yes. Because if it finds it in the database, then is time zone known would be set to true, and then that code in the browser wouldn't run to try to set it.
Makes sense. Yeah.
Okay, and that's yeah. That code runs only if the time zone is not known. So good question. Okay. Yes.
And the code that runs does so every time, like for every session. So if someone moves time zones, then it will update, but not if they set the time zone to a certain, right?
If I move time zone, I need to update it manually.
Okay, but if you don't set a user time zone here, would it be updated manually when you start a session?
Well, you could decide, okay, but in the code that I give you, actually, when the browser tells me and I don't know, I decided that this would write it directly into the database without asking, which is perhaps not the best thing to do, right? The best thing would be that that if it doesn't know me, that if I don't create an account, it would just continue to sorry, what am I saying? What would be the other behavior? No, I mean, there is no good solution. I mean, there is no good other choice, because the problem is this. So if I'm logged in, it makes sense to... No, the only choice that would make sense would be this. If I log in, but I don't define it in the profile, then it should take it from the session each time. But I decided not to do that.
It doesn't do that.
It doesn't do that. I think you can modify the behavior in other ways. I mean, you could modify the behavior in any way you want. For example, you could check if you could store also the last IP address of every user, and I don't know. I mean, the Google App Engine gives you a way to detect the country from which a user is logging in, and you could decide that if you detect a change in country, then you can ask again. I mean, you can do many more sophisticated implementations. Or maybe you can ask every time, what would I do? I would periodically check the time zone of the user, right? Every time the last access has been more than half an hour before, something like that. This would be a sophisticated approach. You still ask the browser to send it to you, but at that point I would read it from the database and say that if the two are different, I may want to have a pop-up somewhere that asks the user, hey, do you want to stay in your original time zone or do you want to update it? I think Google Calendar does something like this. When you are traveling abroad, it detects that your time zone is not anymore the current one, and then it asks you, do you want to see the remote appointments in the remote local time or in your present time? No? And so you could give these choices, I guess, also here. Okay? And the only part that I'm sorry is that I don't want to go into the extreme details of this time zone formatting. Essentially, the call method is called in order to convert a database value into something that you can visualize. No, vice versa. The call method produces the database value, and the formatter method produces a visualizable value, right? And you can read this code and look at how the conversion is done in both directions. Okay? So my recommended implementation would be that you use essentially these conversions on the way in and out of the database. In the server code, not in JavaScript. Okay, when you need to pass dates to the browser, for example, to visualize. That would be a good way to do it. Okay? Okay, so let me get into some other type of thing. So what I want to do as basically the last thing I'm gonna do in the class is, or at least the last JavaScript thing I want to do in the class is this. I want to show you how you can use everything we have learned so far in order to develop for mobile, and also how to develop a small tic-tac-toe game. I used to give a homework asking people to implement battleships in my mobile class, but here I'm presenting this just at the end of this class, so there is no homework covering it, but it's just a nice piece of thing to know. So the idea is this. Notice that in a lot of the work we do nowadays, what is happening? When somebody logs in on our website, we ship them an index.html that is basically constant, right? It contains the Vue.js, it contains the Vue template, basically, and some other definitions, but not very much in the way of definitions, right? To anybody who asks, I give the same HTML template, and the HTML, the JavaScript code is also the same. There is always this default index.js. The only truly interesting things that happen are the things that happen once the JavaScript starts calling back the server, and then it's where your actual data is communicated, okay? So it turns out that mobile phones, as well as computers, can have a browser that runs on the basis of local files, okay? So in most phones, so you have browser applications. For example, you on Android or iPhone, you can install Chrome, Safari, Firefox, or these kind of things. But both Android and iOS give you access at low level to a browser API. So you can write an app that opens a browser window, and that all it shows to the user, or to a certain region of the screen. Actually, you can dedicate a region of the screen on which a browser surface will appear. Okay, this is a sort of unbranded browser surface, and in this browser surface, you can specify which files get loaded. Okay. So this is something you can do based on in Android it's called the native browser. and in iOS, I actually don't know how it is called. Okay, but you can do it in both. So somebody thought of the following. Well, since these applications now that we develop with JavaScript are essentially the first thing I do, I give you the static HTML and JS, and only then the fun starts of the interaction. Why don't we do things in a different way? Suppose I give you an application that packages the initial HTML and the initial JS, okay? And the application is done in such a way that when you launch it, you start this embedded browser and you have it read your HTML file with a link to the JavaScript file. Suppose you do that, right? Then that would be a way to deliver to you an application that makes stuff appear on the screen. Okay? Moreover, the advantage is that whereas Android is different from iOS, which is different from Mac OS X, which is different from Windows, which is different from Linux, etc., HTML and JavaScript work on all these platforms. So if I write my application as a web page that is served by the phone itself, then I can write once and then run on all these platforms at once, perhaps, if I can pull it off, right? So this was the original idea. And so this started as a project that started as, oh boy, I forgot the name, and now it's called Apache Cordova. And once upon a time it was called, do you remember?
They call it PhoneGap as well.
A PhoneGap, right. This is what people called, started via PhoneGap. PhoneGap went on for a little while, or for a few years. And the people who developed PhoneGap wanted to put the code in the public domain, and so they put under the stewardship of the Mozilla Foundation. They essentially donated it or bought it, I'm not quite sure. But the phone under the auspices of the Mozilla Foundation, the code became Apache Cordova, okay? Which to my great perplexity is written with a V, I think. Great perplexity because the city in Spain is written with B, as far as I know, and I'm told that B and V are phonetically similar in the history of phonemes, but it's something that to me doesn't quite square up, okay? But modulo this, the idea of Cordova is this. Let me show you a moment the architecture of files. This is a bit small, but bear with me one moment. So, when you set up, and I will go through the setup the next time. At the moment, I want to show you how the files are put, okay? I will give you pointers to the initialization and how you initialize the environment. But I have a starter app to which I will give you the code, okay? And it contains a bunch of directories. But the point is that all the interesting code will be in the www directory. So there is a World Wide Web directory where you put your code, okay? And then you tell Cordova, please Cordova, produce an application for Android. And then Cordova takes your code and packages appropriately for Android, because what it needs to do when it packages for Android is create an application with a certain icon for the home screen that when launched will launch this browser that will be pointed initially to your .html file that you gave it, right? And under iOS it will need to do the same. So this packaging needs to be slightly different, because the way you start a browser in Android and iOS is slightly different, but you don't have to do it, right? The packaging is done by Cordova, and in Cordova you can simply say Cordova run browser if you want to run on the browser, Cordova run Android if you want to run on Android, and similarly for other phone platforms, okay? So Cordova takes care of the packaging of what you're doing in an application that can be launched. And since debugging is a bit nasty on a phone, and I don't want to get into this right in this moment, I'm going to run it on the browser, okay? But you can equally well run on Android. Maybe for next time I should give you a demo of how to do it for Android as well, okay? So in this www directory, there are the most important pieces are these. There is index.html, which is your single HTML file. So one restriction of Cordova and of this way of developing is that you can have only one HTML file. No? Because when you launch the in-browser, that's the file to which it's pointed to. I'm not sure if there is a way to change it, but I'm fairly sure that it's not important to change it, because as you know, using Vue, we can perfectly well choose which portion of the file is displayed using these Vue if primitives, right? So you have one file, and then you have the JavaScript file that contains the interesting content. So let's look at these files in the empty state, sort of. Index.html looks like this. So this is, by the way, stuff that I have written for you. There is how to say. The original file contained a bit less things, and I did just a small magical adaptation. The adaptation I did is this. Cordova per se has nothing to do with Vue.js. So the only small thing you need to do is to say, please, Cordova, when you launch, load Vue.js properly and activate it properly. I will show you in a moment, okay? So this is very similar to the plain vanilla start of Cordova. You see, I load jQuery because without jQuery I feel lost. I load Vue. I load randomstring.js because I want to be able to produce random strings. This is my own craziness, but I will tell you later why I want to produce random strings. I mean, it's often useful. And then I load index.js, which is what before for you used to be called the default index.js, but it's the same logical role. So I load all those files. Then I have my classical Vue div in which my Vue layout happens. And here I don't put anything at all. I simply say, hello class, it seems that this minimal app is working. Okay, end of the div, end of the body. Okay, so essentially, modulo my loading of the various JavaScript files, and modulo these my app.css, stupid.css, font awesome, and other CSS that I'm loading. This is as plain as you can be, right? Now, what is my index.js content? Okay, so this is it. It's almost the same as the empty app before. Please forgive there is this enumerate, extend. These are just set array attribute. These are just utility functions. Okay, forget about them. I like to have them defined just because they are convenient, but they don't do anything special for you. The only special thing is this. From now on, before I simply had app is equal to app. Okay. Now, not only I have this code, but I say app initialize. This is an extra step for the phone. I need to call this initialize method to my app. This initialize method is implemented here and does the following. Document add the event listener device ready, and it calls device ready. And on device ready, I log it. I show the div Vue, and I say that I'm configured. So what is this messy business? The point is this. Cordova, in addition to letting you run your own JavaScript and communicate back to a server, which is what we will be doing now in the class, gives you actually access to phone resources. For example, to the camera, to the GPS, to the accelerometers, to all this other stuff. There are essentially JavaScript libraries that you can load that give you access to all this functionality. Okay? So in general, when you launch your Cordova app, the phone has to also start those libraries and wait until they become active and well configured. Okay? So when you launch, you need to make sure that not only the browser has read the page, but also the Cordova layer that is below the browser that helps your application have access to the phone is also properly up and running. Okay? So what you need to do is this. You need to say, you need to listen, to add an event listener to device ready. Device ready is an event name. You know that in the other app where we were uploading, we were attaching a listener for the load event to to the file reader, right? So it was a similar thing. When the file reader finishes, it will launch the load event. Here in this case, the document, which is the whole page, when everything finishes its own stuff, there will be this device ready event that is launched by Cordova when everything is ready to run. And so you need to listen to it and to set this value of the isConfigured variable is equal to true and to start doing business. Essentially, if you are in Vue.js, you're not allowed to do stuff before you get that callback to cell phone device ready. Because the phone may not, the infrastructure may not be ready for you to do stuff. Okay? So that's the only other difference compared to what you have been doing so far. Okay? So this is great, and if you have it, you can run your application by simply saying, okay, I'm already running it, but let me rerun it. You say, Cordova run browser. Cordova has a set of comments. Maybe next time I will give you more of an introduction to all the other ones. But Cordova run browser essentially launches Cordova and builds it for the target of a browser. And so it loads it and it says, hello class, it seems that this minimal app is working. Okay? And if we wanted, so just to make a very small change, right? Sorry, let me just git branch. Okay, git checkout branch. I don't know. I don't know. Experiment 1. So, for example, if I edit this code, I can add a variable here that says data like foo is equal to nothing, okay? And then when it's configured, I can say that self foo is equal to banana, no? Of course. And so once I have this variable in this way, then I can go into the index.html. Sorry, where is it? I may not have opened it or I have closed it. Here? Yeah, it opens in the wrong place. Yes. And I can say, I can put another paragraph just to show that the JavaScript is working, okay? So I can say, foo, I called it, I guess. Sorry. Okay, and this hopefully still works. Now, the thing you cannot do is simply reload these, or I don't think it works, okay? Because remember, this is now served from a Cordova build which has as target your browser. Okay, so you are writing the source code, and then Cordova is building this application for you. Let's see where it's located roughly. You see, this is what we write, but then under platforms, there will be one for Android, one for browser, and in the one for browser, there will be a copy of what we're doing. So this is where the target code lives. If you are in Android, instead you will see that there is all the particular setup for building real Android apps. There is Android manifest.xml for the people who have taken 121 and all the rest of the code, okay? So if I change a code in my native directory, in my main directory, it's not reflected in what's served to the browser. Unfortunately, for debugging speed, it's really needed for me to actually stop and relaunch it each time. Because when you say Cordova run browser, it will rebuild the distribution with the updated files that enable me to run it, okay? And so if I do, wait, did I make a mistake? Because it's not displaying anything, right? So did I manage to break stuff? Sorry? Which one? This? Sorry?
So, right after the full delimiter, I think there is an extra character.
Ah. Yeah, but why would this cause an error? I don't understand. I hope you are right, but I'm not convinced. No, the error is not that one. Okay, fantastic. I did two things and I already managed to break something. So where is the error? How do you... Well, luckily we are... okay, so my error is in index.js line 44, which is this line. And it's because, you know, I put a semicolon where it doesn't belong here. Okay? Here. So that was my syntax error. That is the problem. Okay?
You need a colon, not an equal sign.
Where?
The equal sign doesn't work for the syntax there.
No, I need a colon. Yes, you are right. Absolutely right. I got confused. Thank you. I would have got another syntax error. Not very. Okay, and now I see banana. Okay, so that's a way. Okay, thank you. So what I want to build now is a bit of a mental exercise, but I think it's a nice one. So I want to build a game of tic-tac-toe with two people, two separate browsers. Actually, if you will install this code, we will be able to, you know, you would be able to play it even on mobile devices. So I put one piece of laziness in order to make it work easily. And actually, so this was really an exercise that I built for my mobile class. And as I won't be teaching often anymore my mobile class, I want maybe next year to embed it better into this class. But for the moment, I just present it at the end. So I built a server that anybody can use that works on the following principle. You can, if you have a key, you can store a value, or you can read a value. You can essentially put and get assignments of key values. Okay? So the way I'm gonna play tic-tac-toe is this. I have to choose a secret word, which is obviously gonna be banana, and share it with exactly one other person. Okay? So I choose banana, Scott uses banana, and we use for simplicity again, you know, it's a simplified version of the game, but we use a banana as the key to this key value store. And the idea is that in the key value store, we will store the state of the tic-tac-toe game. Okay? The state of the tic-tac-toe game is composed of two things. It's composed of the state of the board, where are the X's and where are the O's of circles, X's and O's, say, and what are the empty spaces, right? And the other piece is which one of me or him is actually circle or cross. And not only that, but there has to be an initial joining protocol, because, you know, first I'm going to join and say that I'm banana. And then he hasn't joined yet. And so there is a bit of handshaking for being able to, you know, handle the case of, you know, there is no player yet. Well, that's not a problem. There is one player only. There is only the other player, and there are both players, and the game can actually start. Okay? So there is a little bit of handshaking done in this way. Now, the first choice to be done is how am I gonna implement the game? So clearly, if I'm gonna play with Scott, I and Scott have to somehow exchange information when we move. And there are two sort of issues, you know. The first is how do I actually communicate with Scott? And the second is what information do I send? And I just want to describe in a moment these two issues. The first is this. I think you know the answer to how am I going to communicate with Scott. And the answer is, well, I don't directly, right? So I don't talk to Scott. I talk to a server, and he talks to the server too, and then we exchange information. So I think it's an interesting thing that by this time you will have become familiar with. But there is all this talk about the mobile internet and peer-to-peer devices, etc., etc. Well, maybe Bluetooth is peer-to-peer, and other things may be peer-to-peer. But by and large, the way with which you communicate with anybody else is generally not peer-to-peer, right? Is like really server-client architecture. So we are going to do server-client architecture also in this case, because essentially servers have a known publicized API and address, but mobile clients don't, right? So I wouldn't know. And moreover, there are all kinds of security restrictions. So even if I knew, I don't know that he would be able to serve, have web pages or answer to low-level APIs. I mean, not easily in HTML. Now, the other interesting point of to decide is what do I send? For example, if I play tic-tac-toe with him, I could decide that I send information such as B2, and that means I play, depends on whether a number 1, 2, 3 or 0, 1, 2, but B2 if a number 1, 2, 3 would be the center move, right? And he would reply with, I don't know, C1, and then we could go on. That is, the idea is that you transmit moves. Instead, I'm going to do a different implementation, which I really recommend as a way of thinking. You always want to transmit state, not change, okay? This makes for much easier to write protocols where you want to reach a consensus state of the world. So, and I want to take a moment to make this point, which is quite beside this particular class, but it's true in general in many things that have to do with computer science. That is, over a lossy communication channel, and we are communicating over lossy channels, because if I send messages via cell phone, I might be in an elevator, he might be in a tunnel or whatever else. But if I communicate over a lossy channel, messages in an asynchronous way, I send a message, sometime later at his pleasure, he will send a message back to me, there is actually no way to reach consensus. Okay? You cannot create a single shared vision of the world that is known to be shared by sending each other asynchronous messages with news information in them. And I have an example that shows why, and then I want to show you how we overcome it in this game of trees, okay? So the simple example is this. Suppose Scott and I have to decide what to do tonight, and we want to decide whether to go to the movie or stay home. And we would like to either show up at the movie or both stay home. But we don't want that one of us goes alone, right? It's kind of not so nice to go to the movie alone. So, rather than giving each other a phone call or talking to each other, we are going to send each other, SMSs without notion of whether the SMS is received or not, suppose. So I sent him an SMS that says, hey, let's go to the movie. And then I don't hear back. Did he get it or not? Boo. Well, so maybe we agree before, hey, when you get my message, reply so I know if you are going. So I say, Scott, let's go to the movie. He replies, yes, let's go. And now I start to wonder, well, yeah, he said to me, yes, let's go, but he doesn't know whether I got a reply or not. So can he go to the movie and be certain that I will show up or not? So maybe we should do one more round, right? So that he's sure that I got his reply. And I say, Scott, let's go to the movie. Yes, let's go. Got it. No? That's somewhat better. But can he actually be certain? Because, now I don't know whether he got it. So do I know that he's certain that we will both show up at the movies or not, right? So for this particular problem, you can show that shared knowledge cannot arise on lossy asynchronous channels. And the proof is very simple. It's a very beautiful classical proof, which I cannot find. No, yes, where is it? Okay, imagine that instead of Scott and me, these people are A and B, Ada and Bob, as in, security So Ada sends to Bob, Bob sends to Ada, Ada sends to Bob. So this Ada says, let's go to the movie. Okay, got it. Yes, I know. Thank you, see you there. No, I mean, there is this protocol that these two friends develop, okay, and they follow it. Imagine that at some point they both decide, at the end of, suppose, of these various steps of back and forth, they decide that they are both certain that they can go. First of all, what is a consensus protocol formally? What are its properties? Its properties are these. When it ends, both players have to be certain that a common choice has been chosen, okay? Moreover, and this is a subtle and semi-obvious point at the same point, the common choice at the end of the protocol has to be an original choice of at least one of the players. This seems obvious, but otherwise I can invent a consensus protocol that works this way. The consensus protocol says, stay home. You know? Maybe we both wanted to go to the movie, but you see, if the protocol works that way, it's not really a communication protocol, right? So you want to ask, that at least one of the choices of a player, the consensus choice was the initial choice of at least one of the players. So imagine that at the end of this long consensus protocol, they reach the consensus, which I simply indicate as C, actually without parentheses. I write it C. C means consensus. Okay? So after this long chain of transmissions, after B receives the message from A, whatever this message contained, this is a general proof. Imagine that there is consensus possible. I'm trying to argue that this is impossible, so I'm trying to reach a contradiction from this. Okay? So, but imagine that somebody invents a complicated enough protocol in which every message contains in a blockchain way, which is really fashionable, all the encoding of the previous messages, and you do these, and people blow up terawatts. Okay? Now consider this from the point of view of A. A here is about to send the last message to B, and A knows this. If B ever gets my message, B will reach consensus. Not only B, but the protocol will reach consensus. Okay? So I have this message here. If I send it and gets to B, consensus. So if I send it, however, I will not hear of anything back from anything anymore, right? Because that's the end of the protocol. So if I send it, I know that the consensus is going to be C. So essentially, by the moment I send it, notice that the message could get lost, right? So I have already to reach consensus here, because if I didn't reach consensus here, and B has to reach already consensus here, no? So this situation in which I'm about to send the message, no, B has sent the message to me. I'm sorry, I did this way for the people who are who are home, but for the people who are here, let me draw it in a better way, because it doesn't quite work in that way, because it splits the person in two. I mean, that's a problem. There is A, there is B, there is A, and there is B, and I think that's enough for our purpose, okay? So imagine that once B gets the message, B is in consensus. This message might get lost. So essentially, A here at this point has already to know that the state has to be the consensus state. Okay, because I will not observe any difference between these happening. So A needs to commit to C at this point. Now consider B at this point. B knows that if B sends the message to A will commit, regardless of the destiny of this particular message. Okay? So when B sends the message in this moment, B has already to have in mind his final choice, the consensus C. Right? So let me begin again from the end, going slowly. If the full protocol is executed, B at this point commits to C. Let's say going to the movies or stay home. And the protocol is known by both, right? They both participate. So A at this point, the one step before the end, knows that upon sending the message, it will have to do C. It will not receive any other acknowledgement, okay? Great. So at this point, effectively, A is committing already at this point to C. Because from A's point of view, whatever happens next, it doesn't matter, right? And then look at B here. B knows, well, if I send the message to A, there are two cases. A gets the message and then C will happen. Or, you know, maybe the message gets lost. I will, and they may have to commit at that point. So I have already to have committed to C at this point. And so you see that essentially from B, you can go backwards, and already from the beginning, they have to have had the choice of C as the common commit, which is impossible because at the beginning, you know, if they know it at the beginning, then it's a constant protocol. It's one in which they always choose the same thing. Okay? So this is a paradox that happens all over the place in computer science if you try to do things this way. So you may know that, you may think that now you communicate with a server and you can get a somewhat reliable answer of whether the server got you a piece of information because you can tell me, okay, but I can look at the HTTP return code. But, you know, that's only a statistical insurance. It doesn't really tell you whether the server did or did not do the transaction, right? You can be talking to a server and getting a disconnection error, and at that point you really don't know whether the server did or did not do the database update that it was supposed to do, okay? So the only way to reach a consensus in these things is to move to another protocol in which instead of communicating change, you communicate state. In the case of tic-tac-toe, what I will not be sending, I play in B2 and then wait for some kind of confirmation. There is a representation of the board, and the game is nice enough that it's monotonic. You know, you can only add marks to the game. So, you know, I can continue sending, hey, this is my board, hey, this is my board, hey, this is my board. And if I get a board from me and a board from him, you can always reconstruct, if none of us is cheating, a consistent version of the board, right? Because you simply take the marketplaces on my tic-tac-toe, the marketplaces on his tic-tac-toe, and you know, they have to, I mean, one of us has to be ahead of the other by 1. Otherwise, we couldn't play, and we can reconstruct the state of the game. Imagine another situation, which is, you know, the prototypical way of reaching consensus. I go on a trip, and I want to charge expenses back to my whatever, university, haha. As if, no, jokes aside. But imagine I did it, right? So I could go and have a coffee and, you know, plank, you know, 3.25. And if I try to communicate this change, you know, we would go in this loop in which most of the cases would work because, you know, most of the packets make it through. But I would never exactly know whether the charge is registered once or twice or so, right? So what is a solution to this? A solution to this, I mean, you probably have encountered it many times if you take classes such as operating systems and file systems, is to convert a problem of transmitting change to a problem of keeping logs in sync. So instead of saying that I spent 325, I create maybe a long random ID like Git does for my expense, and I say A, B, C, D, E, F, 325. So I have a list of transactions with their IDs. And so I have converted a problem in which I have to send something exactly once with a reply to a problem where I just need to agree on state, where I can keep trying as many times as I want to retransmit it back to the server, right? So I may have a list of transactions. Every transaction has an ID. And I methodically tell the server, hey, these transactions happened. And I hope that eventually the server will acknowledge some of those transaction IDs. When it acknowledges them, I can strike them away from the list I need to communicate to the server. But there is never the problem of not knowing whether I communicated it because I keep trying until it tells me. And there is never the problem of communicating something twice because if I do, the server will see that the transaction ID matches, okay? And so we'll simply discard the knowledge that is already common, okay? So essentially, I want to build a protocol based on sending out information and creating the consensus. So the next element, the next part of the protocol, which we will do next time in class, will be something like this. We need to figure out how to encode a tic-tac-toe state as a string so that we can send up and down from the server. And then we need to do some fairly simple operations that when you touch the screen, I need to switch on the X or O in that particular box, and I think you know how to do it with Vue, and update my local state. And this is kind of easy by your pointing class. And then I need to do the slightly more touchy thing, which is I have my local state, I ask the server for the remote state, and now I need to merge them, which is almost easy. Except that I have to make sure that we merge them in a way that is ahead in time. For instance, if a box is white on my state and is a cross in the server state, the merge has to be cross and not white, I mean, obviously. So you need to listen to the most recent of the versions, essentially, of each square, okay? And that's what we will be doing next time, okay.